drift in the world of LLMs. Now, there are 7 steps to prompt engineering for time series. The first one is to understand the temporal context, because time series deals with the evolution of data over the period of time. So that evolution of data is time to time. Is also to a large extent tied to space, and also other factors that you cannot be able to spot them immediately. So incorporating the time-specific information into trend is very, very crucial. Now, we need to also talk about future extractions. How do you extract futures from a time series data? Because the time series data has so many components, such as peaks, such as seasonality, and all that. So how do you extract this trend and be able to spot what you are looking out for? It's very, very important. And how can LLM helps you to do that? Is very crucial. Now, there is also another thing talking about hybrid workflow. How do you combine the LLM with traditional statistical model? In fact, currently, that's one of the things that I'm trying to work on, because I discovered the current LLMs do not really have interpretability embedded in it. So when I am proposing, of course, in the area of public health, is how do we introduce explainable AI technique into prompt engineering, kind of RAGs, agentic AI, and so on. We want to find, not just leave these things to chance, but at the end of the day, if an agent AI pull a particular reference and recommend a particular drug, we want to know what happened. Why did it select that particular paper? Why did it select that particular drug combinations? We want to know these things, and then at the end of the day, we will be able to tell the medical expert if they should trust these systems or they shouldn't, because there seems to be a gap in these things. Like I also told you guys last week, that when you looked at the training bias, most of the data that used in training these large language models comes from the global north. So when you are looking at a scientist in the global south, or a medical expert working in, let's say, a rural village in East Africa, they are not exposed to this kind of information that is being used in this part of the world. So if you are transferring some of the recommendations from the LLMs to be used in such context, we need to localize it to a large extent. So they need to have reason why they should trust this recommendation, because beyond just the recommendation made by these recommending engines and all these large language models and AIs, we need to understand that medicine doesn't just work like that. It's, to a large extent, medicine is personalized. It means that there are other factors like genomics, like environment, and also family history and all that we have to put in context when we're recommending treatment. So the same disease, but different trajectory. So if you are now trying to apply the same treatment approach to that particular patient, there is high tendency that that will not work. So that's why these days we're beginning to see a lot of resistance, for example, in treatments for malaria. To a large extent, we may agree that yes, the mosquitoes may have evolved over time and developed some level of resistance towards maybe pesticide, and then they find a way to, bring in this new form of strands of the parasite that is very, very resistant to drugs. But again, we need to ask ourselves if the drugs that we are producing were actually done putting the context of the global south into play, because most of these places that is being plagued by these diseases for example, have a complete genome sequence of the population of people there. So this kind of thing, we need to understand how these features are being extracted. So we looked at all that, and then we need to talk about, like I said, how the traditional statistical model could help. Because for me, for example, I'm of the opinion that we can use some of these traditional statistical models we have, embed it into the LLM workflow, and they can help us to, give us that clarity and also give us some of the associations, of course, not the causality of why some of these things happens. Then we'll talk about the schema-based data structures like the JSON. How do we structure the data in such a way that the computer will be able to relate with it? Because like I told you that the AI is acting on garbage in, garbage out. If you don't have a good data for it and you don't present it in a very organized way, you have the tendency of the AI just making up things, and then at the end of the day, your results will not be correct or consistent. So you need to take note of some of the things. So we'll also talk about, or we're going to look at how you can forecast future patterns. How do you write prompts? Some of the examples of prompts that you could be able to use to make forecasts. Anomaly detection. These days on real time, anomaly detection is very crucial. So ability to actually identify and interpret it is very crucial. Then the domain knowledge, very, very important. AI become much more useful if we introduce the domain context, because most of the time, we cannot properly understand this AI if we don't give it a role to be able to work from. Because, like I said, imagine this thing, AI being trained with all the data on the internet to a large extent, and then you just come and tell it, do this for me. It's kind of vague, but the moment make the AI to assume an expert role in relating to something, it will be able to understand what you are trying to say. And sometimes also working with the knowledge of the experts, like from literature and all that, it's very, very helpful in guiding you to make accurate decisions. So let's see how it goes. Again, before we talk about uh, prompting type series, we need to understand in brief what prompt engineering means. So the large language model, or LLMs, are we looked at the architecture last week, and we said that one of the interesting thing about it is the use of the transformer model. And we said the transformer model have an interesting decoding and encoding architectures. And then we also talk about the fact that one of the things that make the transformer model very interesting is because of the attention components of it, meaning it gives a certain level of weight to a certain part of the corpus that we put into this model. So while we're training, it has this ability to to understand the context better than the traditional NLP that we have been using. So we can use the large language model to leverage data analysis tasks, because we are now in an era where this large language model can write scripts for us, even more than that of the entry roles. So we don't need to waste a lot of time trying to do these things ourselves. But that doesn't mean we shouldn't use our brain. But like I said, take the AI as your research assistant, then it makes sense. So you are like the supervisor or the line manager where the AI reports to. So by the time you tell it what to do, it does it. Then you looked at it in order for you to understand it. But again, it makes sense if you yourself actually knows it, because for you to be to assume a supervisory role, it means you must have had the knowledge before now. So that's why I tell people that it doesn't mean coding is not relevant, again, because of the AI could do all these things for us. But it makes sense if you know the codings. For example, when I'm working with this large language models like ChatGPT and all that, the moment I'm beginning to see things that is not right, I could just tell it and say, what you're doing is not right. This is what you're supposed to have done, because this will lead us to this. So you need to understand, you need to know some of these things. So when you run into some errors, you can be able to debug them, and you know why that error is happening in the first place. So when the AI could be able to do some of this traditional data analysis pipelines even much better than an entry data scientist could handle it, or data analyst. Okay. Uh, Including specific scenarios such as time series analysis. So even time series analysis, and if you know time series, if you are a statistician, one of the interesting class that we look forward to in your course program is always time series, because that seems to be one of the areas where you're looking forward to learn about seasonalities, trends, and all that, especially if you want to end up in banking and finance, or probably if you want to go into weather forecasting and all that, so you need this time series knowledge. So it's always a class we look forward to. So, but today, AI can do that for us, and how would AI be able to do that? Through prompt engineering. And we say prompt engineering is the practice of crafting or designing and refining input instructions to guide a large language model to produce accurate, relevant, and reliable output results. It means that the prompt has to have first task, which has to be clear instructions, two, context, which constitutes the background information. Like I said, what kind of role or what kind of domain you want the AI to work on, then the input data itself, and then the output indicators. So you don't just tell the AI, do this, but you have to systematically tell it what you want it to do for you, in what kind of context you want it to do it, and then how did the examples of how the data you're giving to the AI, and then how or what you should expect. The reason is because if you are vague, you will likely get a vague result while relating with the AI. Now let's have a recap on the traditional time series approaches. You see, the traditional time series are very, very important. We have the moving average, if you one of them. You will also have things like ARIMA, we have SARIMA, we have the VAR, we have so many models. However, they rely strongly on assumptions of linearity, stationarity, fixed temporal structures, and require substantial future engineering. So this makes them to be very brittle, to and rigid to change. Again, when you're looking at irregular data or missing values or complex sort of interactions, or some of the semantic influences, you begin to see that it has a lot of limitations. And again, you see, the real world is very, very uh, complex to a large extent. It's not Uhuru. It's not really going to be always in CSV file format. It's not always going to be direct. So when we look at all these things, and sometimes you're racing with time, to build these models it requires you to understand how to use, for example, R, how to use Python, how to use maybe SPSS and all that. When you look at the time you invest in coding, in doing those things, sometimes it makes sense if you know how to use AI, then AI could help you. You can work along with it to get results quickly, and then you could be able to relate to it. Imagine if you are sitting in a board meeting where you need to give results or feedback directly to stakeholders. The stakeholder doesn't have forever to wait. And when you are talking about time series, again, you have to know that the value of the information is in time. So if you don't work to beat the time in order for you to get this information out, then you actually it loses its potency with time. One example is social media. most times if you see videos or news or things from last week, sometimes it doesn't really make sense. You will just skip it. You're always looking. The reason you are scrolling is because your brain uh wants to be current or updated with what is really happening. It wants to follow the trend of what's happening. But of course, there are internal truths that are encapsulated in time that no matter the years, no matter the period, once you come across them, they look very fresh, But these days, a lot of brain rot contents have, they have a very little lifespan of of trends. So if you don't really watch them in the moment, they are not relevant. I don't know if you understand. For example, there are novels that when I sit now, I remember them. I want to go back to read them. I was talking to my wife the other day about this novel called The New Man, which I read when I was still in secondary school. And I was telling her, I said, this novel is actually what's happening in Nigeria today. Looking at the case of Nnamdi Kanu, although Nnamdi Kanu was fighting for the Biafrans, but it's similar kind of story of an idealistic man that wanted a new man concept, which is going to be a man that is morally just, that is free from corruption, tribalism, and all sorts of indifferences that have kept the country small. But unfortunately, this new man, in the process of time, he went through prison, he lost his loved ones, and then it changes his thoughts and he became something else. He even made it to become like the chief of defense staff, and he became very brutal, fighting on the ideology he himself stood for, and all that. So such kind of information is a kind of an internal truth. So for example, I came across a video yesterday or so of an interview that was held with a young northern person from northern Nigeria around 1967 during the period of the Civil War. He talks about how Nigeria is going to. He was discussing it with a professor in US, and the professor told him that, look, we are not really interested in Nigeria. In fact, the reason we are interested in Nigeria is because Nigerians are very intelligent. They also have resources. They also have the market. So by the time you leave them uninterrupted, no any other parts of the world will compete with them, because they can take their resources, mine it, refine it, and use it to develop themselves. They have the market to be able to sell among themselves. So this country doesn't really need any other country to stand on its feet. However, if we leave you guys to develop at the pace you want to go, you won't need us, and we would have to be the one begging you in return. So because of that, we have to find a way to create a problem, and then you guys will keep solving the problem. When you finish that one, we create another problem. So she was like, even when the civil war finishes, they will continue to create problems for Nigeria, so they will not solve it. So when I was looking at it and reflecting on that information, I was like, actually, this information, it makes sense, because Nigeria was moving from one ripple effect to the other. After the Nigerian Civil War, it was a series of coups that were following, then the incidents of Meitasine, then the June 12 annulments of Abiola, then even down to the early 90s and down to the 2000s. Then the 2000, we started talking about Sharia, and some radical Islamic elements enters into the north, and they were preaching a very strange doctrine that was not used to the people. Then in metamorphosis, gradually I became Boko Haram. And then from Boko Haram, they splitted and became ISWAP, and they continue, now it metamorphosis into banditry. Can you see the way the evolution is going? A time came, it evolves and become a Fulani militia. Can you see how this thing goes? So we need to sit down at the end of the day to understand why our problems are coming and how can we be able to tackle them, so we stop this evolution into a catastrophic end. Anyway, so I was trying to make you understand that these traditional approaches to time series are not always flexible that we could be able to work, especially if the data becomes so complex. So the prompt-based time series approaches leverage foundational models to incorporate contextual, semantic, and cross-domain information directly through prompts, enabling flexible adaptation, zero or few shot forecasting, robustness to non-stationary, and reduce manual feature engineering. So what are we trying to say is that we can use this prompt engineering approach to be able to analyze this time series. One, it will save us a lot of time. Two, it's very, very flexible because it will extract this semantics and contextual cross-domain information directly from using the prompt. You see, so to a large extent, it relaxes the assumptions that the traditional models are carrying. But again, I am not of the opinion that you should just go with the prompting alone. Rather, you can use the hybrid, meaning you can combine both the traditional and also the prompting based approaches. Okay, now we talk about 7 guides to prompting time series. The first one, like I said, is contextualizing the temporal structure. An effective prompt to get a useful model needs the output should be one that helps you to understand the temporal structure of the time series data. You need to understand how these temporal structures are evolving in time. This includes you need to study first the upward and downward trends, two, the seasonality, the peak cycles like promotion, holidays, and so on. This context information will help your LLM to interpret, for instance, temporal fluctuations as well as the fluctuations rather than noise. I remember in my university days, one of the very interesting topics is on queuing theory. And in fact, I've written either 2 or 3 publication in queuing. Quite interesting, quite interesting. But again, with the current time series prompting approaches that are available, I was beginning to wonder if we can be able to use prompting to help us to be able to understand queuing better. Because the queuing, one of the problem we have in queuing is the fact we can have exploding queues, like especially in seasonal periods like Christmas and other holidays where the orders or people are placing orders or people are arriving at public institutions like banks or other kind of places rapidly. So when you look at that kind of time, that period, you see the queuing periods would increase, tremendously. So maybe something that should take you 5 minutes now has to take you 1 hour, if not more. So how do we be able to manage that kind of peak periods? How do prompts can help us to discover a sort of an approach for us to be able to meander through these things so we don't the system will collapse. So stuff like that, prompting can help us. And now let's look at an example of how a prompting could help in understanding the contextual structure in the time series data. Now, excuse me. Here is a daily sales in unit for the last 365 days. The data shows a weekly seasonality, high sales on weekends, a gradual increasing long-term trend, and monthly spikes at the end of each month due to payday promotions. Use that knowledge when forecasting the next 30 days. So you can see that looking at the data like this, you can't write this prompt if you don't really know much about this data. Do you understand? So if that's why I still told you guys last time that you need to have some trial knowledge of this coding analysis and all that, because it helps you to really be able to communicate effectively even with computers or large language models. So for example, for me, what I need is to get the data, do some EDAs. Then from the EDA, I'm going to be able to identify these high sales on weekends. I'm also going to see the monthly spikes. And then that will now help me to be able to make this forecasting for the next 30 days. So you see, the traditional approaches are not useless. They are still okay. But again, the prompting can still help you. So you can still write a prompt, for example, to tell the prompt to perform the EDAs to identify high sales, to also be able to identify monthly spike. Then take that information and craft it in the next prompt that you're going to give the LLM. So that way, you can be able to do all those things without you having to even punch any keypad for your traditional analysis approach. Good. Any question on that? All right. I assume there is no question. Now, futures and signal extraction. You see, you need to extract the futures because the futures is what will really help you to be able to uh, understand what you are trying to analyze. And in time series, what we are interested in is signals. We're really looking at that signals, which means what we are looking at is directionality. We are looking at peaks. We are looking at cycles. You know, stuff like this are very, very crucial for us when we are talking about time series data. So most times when you see those stock exchange graphs and all these bars or sticks, you will see that most times you are looking at when a particular stock goes up, you now be able to know if this stock will maintain this pattern. So, but again, you will now go back and look at how the cycles were in the past. You now be able to know that, okay, what must have caused this spike? Like last time I read about the tweets from Donald Trump on Cummins Nigeria gone blazing, to face the terrorists. And someone said immediately Donald Trump made that tweet, a lot of investors started withdrawing their money from the Nigerian stock market, and that caused a lot of panic. So you see, so sometimes there could be this sudden shock at the market, and that could lead to crash. So you need to study all these kind of things, so it could really help you to be able to forecast. Because again, when you're talking of forecast or prediction, you're not certain, but looking at these previous cycles, it may not be different from what we should expect in the future. So let's look at an example of that. So through summary statistics or decomposition, it could help to reveal the reasons behind the future predictions or the fluctuations. So example of prompts that can help us to extract signals and futures is one from the past 365 days of sales, compute the average daily sales, the standard deviation, identify any days where sales exceeds the mean plus twice the standard deviation, e.g. potential outliers, and note any recurring weekly or monthly patterns. Then interpret what factor might explain high sale days or dips, and flag any unusual anomaly. So this kind of prompt will now help you to identify some of these things. So all what you just need to do is to get the data prepared in maybe CSV Excel file, upload it to, of course, not the, I see these days we have the Microsoft 305 co-pilots where organizations customize it. So that maintains that level of data privacy. Because one of the issues you have to really take note of while relating with things like ChatGPT, Google Gmail is the privacy concern. You don't take data that you are not supposed to share in the public to come and be sharing them on this platform. So make sure when you are sharing CSV Excel files, make sure it is really a file that, maybe the data is already on public repositories, and maybe you have the consent of those that, you generated the data from. So make sure all this privacy ethics side of it is settled before you start talking of uploading data in this domain. So be very, very careful because these data need to really be protected. You protect data. It's not something you joke with it. For us in the medical domain, it's kind of a must. We don't go about sharing data. We have to be very, very sensitive to protect the information that we're working on. In fact, the moment you finish working on a particular project, you destroy the data completely from your computer. So you don't have any record of it, and all that. So you have to be very careful, okay? So you don't share sensitive information that can implicate you in the future. All right. So assuming you have all this settled and of course, you can upload the data and then you can work on it. I talk about the hybrid approach where I said the traditional statistical approaches are not completely obsolete in this period. Rather, they really help us to be able to understand certain assumptions and also help us to be able to understand better by providing clarity and some sort of explainability to the rationale why complex models make decisions. So combining combining LLMs with statistical approaches that have already been used in the past is what we can call hybrid LLM plus statistical workflows. Okay, because now the LLMs will use the knowledge of statistics that have already been established in this area in order to be able to make the decisions more accurate. Because LLMs in isolations will often struggle with tasks requiring numeric precision and capturing temporal dependency in time series. For this reason, simply combining their use with classical statistical model is a formula to yield better outcomes. So how could a hybrid workflow like this be defined? The trick is to inject LLM reasoning with high-level interpretation, hypothesis formulation, context comprehension, along with quantitative models such as ARIMA, ETS, and others. So what you need to do is you take the high-level complexity of the LLM, the high-level intelligence of the LLM in helping these traditional models to be able to formulate the hypothesis and also to understand what the traditional model are analyzing for you. So it's very good if you could work together by injecting these things in the LLM. So that way it gives you something. A very good example is the Limoly, that's the LLM enhanced mixture of linear experts. So it's an example of a hybrid approach that enrich the linear models with prompt derived features. So you can click on, and I think this is a link. There is a link to this particular limo, which I actually put as a markdown. So once you clicked it, of course, it will open to that particular site, and you can study it further to see how you could use it. The schema-based data representation. While raw time series datasets are usually poorly suited formats to pass as LLM inputs, using a structural schema like JSON or compact table could be the key that allows the LLM to interpret this data much more reliable, as demonstrated in several studies. So the computer loves when we put data in structures or schemas, because the computer itself, when you looked at the rationale behind how it pulls and manipulates data, most times it likes when you structure the data in format like JSON. Once you can be able to extract those data from, let's say, just raw text and manage to put them in JSON format. In fact, one of the app I developed last time, if I'm not mistaken, is an app that once you put a normal prompt in, it could make them to output them in JSON format. I think I put it on Streamlit Cloud. Very interesting kind of, because sometimes it makes sense if you write in your layman human language, but then if you want to relate it with the LLMs for better results, it puts them in that structural schema approaches. And that was what I did. I just put them in schema. So the moment you say, hey, I want you to do this for me, then it just picks it and puts them in schema. Then you just copy the output and put them on ChatGPT, and then from there you get a more structured result. So that kind of approach is really makes sense if you put them on this kind of tabular format, or you put them in JSON format. Now let's look at this. This is an example of a snippet of how this data was put in a very structural format. You can see this is the sale. So this is more like a dictionary if you know your Python, okay? This is a dictionary kind of, or library sort of organization. So we have the sales, and then we have the date, and then we have the metadata, which is the frequency, is daily, seasonality, domain. So by the time you're giving this to the LLM, it's actually going to see it's in a friendly language that it's very used to, and that it could be able to analyze it better for you. We have the prompted forecasting pattern. Now, designing and properly structuring forecasting pattern within the prompt, such as short-term versus long-term horizons, or simulating specific what-if scenario, can help guide the model to produce more usable response. This approach is effective for generating highly actionable insights for your requested analysis. So again, if you are forecasting, it makes sense if you can do for just a very short period, and then you can also do for a long period. Then you can, at the end of the day, compare them and see how accurate these things could be. Then another way, you can simulate different what ifs, and then you see how this process look like. A good example of a prompt is, let's look at the first task is to forecast short term. It means in the next 7 days, forecast the expected sale. Task B, that's the long-term forecast. In the next 30 days, provide a baseline forecast plus 2 scenarios. Scenario 1, normal conditions. Scenario 2, with a planned promotion on days 10 to 15. In addition, provide a 95% confident interval for both scenarios. So that kind of forecast makes the model to really gives you something that you are more sure of. Because one of the issues we are really struggling with in the LLM era is cases that has to do with uncertainty. The issue around uncertainty is really become a concern. For example, by telling the LLM to provide you with 95% confident interval, really do help to mitigate some of the issue, although not eradicate it all, but at least to a large extent, it's able to really give you that assurance that whatever decisions you are making, you are not really going out of the hypothesis that you have already formulated to a large extent. Although this is not certain, but to a large extent, you are sure of what you are trying to do. So that uncertainty is quite a concern, for someone like me working in the medical field. One of the issues we are really concerned about in the era of agentic AI, RAGs, and multi AIs, agentic AIs, it's how do we deal with this uncertainty quantifications? How do we quantify them properly to be able to trust the systems? Anomaly detection prompts. This is one task specific and focus on properly crafting prompts that may help not only forecast with LLMs, but also detect anomaly in combination with statistical methods and reason about their likely cause, or even suggest what to investigate. The key is once more to first pre-process with traditional time series tools, and then prompt the model for interpretations of findings. Because anomaly is very crucial, especially if you are in areas that are very sensitive, like finance. One of the things you're going to be looking at, like if you are trying to mitigate fraud, like fraud detection tools, for example, it's something that happens once in a while. It's not something that is very reoccurring as such. So it's very difficult to catch because it's very underrepresented in the data. So you need to craft your LLMs prompts in such a way that it could be able to investigate these things. So it makes sense if you use the traditional to spot it, and then the LLM can be able to really understand what's happening, and it could pinpoint the reason why this thing comes up. You know, uh, sometimes we need to know that, like I always used to tell you guys right from last cohort, that we are going to be seeing a lot of cyber attacks. We are going to be seeing a lot of internet fraudsters, you know, advancing rapidly, especially in this large language model era, because now they seems to have the tools, and the experts are not really catching up to a large extent with some of the techniques that are out there. So we need to be very, very sensitive and moved at the pace at which some of these hackers and these criminals are moving, so we can mitigate them, you know, to be able to. In fact, if we can be ahead of them, it would have made sense. But sometimes, you know, this is more of a reactive. It's maybe when they have developed a method and used it, and then we now try to counter it and all that. So we need to do more in these areas to mitigate the risks, because this advancement into agentic AI that we see, you know, and now talking about edge AI and some others, you know, we're really moving very fast. So if we don't think about how we can also match this prowess, then we will really be in trouble. You know, we'll see more of these things happening rapidly. So an example of a prompt is this: use the sale data JSON. First flag any day where sale deviates with more than 2 times the weekly standard deviation from the mean. Then for every flagged day, explain possible causes, e.g. out of stocks, promotion, external events, and recommend whether to 1. Investigate the inventory log, marketing campaign, or the store foot traffic. So this helps you to be able to properly relate with the LLMs to identify these anomaly detections. Because, you know, like I said, we're in a season where we are going to be seeing spikes in some of these anomalies, you know, because of the advancements that we have gotten in AI recently. So if we don't find a way to use the same AI to help us to catch these defects in the system, we could easily run into issues that could be very problematic. Domain infused reasoning. Like I said, the domain context is very important. We don't just relate with the LLMs. We need to understand how these things are doing, and how, by giving them rules, by interacting with them from a different level based on literature or some sort of guidelines. So domain knowledge like retail, seasonality patterns, holiday effect, etc. uncover valuable insight, and embedding it into the prompt helps the LLM to perform analysis and predictions that are more meaningful and interpretable. This boils down to leveraging the relevance of dataset context, but semantically and domain specific as the lighthouse that guides the model reasoning. Like I said, again, the domain knowledge is very, very crucial. Like I see people, even in most universities, like I used to always object that, why do you in university says you are training statistician or computer scientists or mathematicians? In what specific area of mathematics? Are they doing industrial mathematics, or do you just want them to be purely theoretical mathematicians or and all that? Because if you don't give context, the knowledge is very vague, and that's why when training graduates, they are coming out, they don't know what to do, they don't even know where to apply some of these things. So what am I trying to say? If we are training statisticians, for example, We need to train them in areas such as biostatistics, where they could focus purely on biological models. We can train them to become industrial statisticians, where we train them to understand how to relate with, let's say, quality control units. You can also train them in area of weather, that's forecasting and all that of weather. So they purely just going to become statisticians that specialize in these areas. And train them as financial statisticians, where they go into the finances and all that and all, so stuff like that. So we don't just produce them statisticians without having a specific expertise in a specific domain. So giving it a domain will make it to be much more useful. Okay, and that's what we are trying to talk about when we're looking at this prompt engineering for time series. By focusing on a specific domain, we give it a context. This is an example of a prompt that we can use giving it a domain. So we say this is the daily sale data of the retail chain. Sale tends to spike at the end of each month. Customers receive salaries, drop on public holidays, and increase during promotion events. There is also an occasional stock shortage, resulting in dip for certain SKUs. Use this domain knowledge when analyzing the series and forecasting. So you see, you have given it a prior knowledge ahead of time that this is what had happened in the past. So looking at some of these things, then use that to guide you into the future. So stuff like that. The domain is very, and you can get this by, for example, going to um the company or going to the supermarket, talking with some of the workers there, have some sort of understanding about when they have these spikes, when they don't have these sales, when they tend to have out of stocks, what could have caused it. So by the time you have all this knowledge and you come back and relate to it, you will do a very thorough investigative job. One of the problem we are having is people are producing what people don't want. So if you produce a knowledge people don't want, that knowledge will not go anywhere. So, but if you are working with what people actually want, and that's one of the things that I coming up as a researcher, I just wake up, we get excited, we just pick a topic and then we go into it. So I discovered that was not how to do research. You do research based on the demands that you have at hand. What are the current issues of priorities to nations, to countries, to organizations, to people? So by the time you understand that, then your research will make a meaning. Because if you just go about pick a topic that you are excited about, but no other person is excited, then your knowledge, nobody will use it. So the reason people will use what you have produced or what you are trying to study is when there is a demand for it. Do you understand? So these are the kind of things. If you want to use AI, then you need to understand how to properly use it to solve a problem. If you want to, for example, help somebody that is in the supermarket to do better, then you need to go and relate with the person. What kind of problems are you having? How do I understand this problem? By the time I understand the problem, it will help me to be able to frame my research questions and hypotheses. And that will make me to properly be able to know